This example is about Benford's law, so make sure you watch that video just to get a little sense of it before we start here. So when an accounting firm audits a company's financial records for fraud, they often use a test based on Benford's law. So that states that when there is no fraud, about 30.1% of the numbers in financial records should begin with the digit 1. If the proportion of first digits that are 1 is significantly different from 0.301, the firm does a more thorough investigation of the company. So let's say there was a random sample of 300 expenses from a company's financial records and that they got 68 expenses that begin with the digit 1. So our question is, should the company do a more thorough investigation? So let's start off just by looking at what we've got. So we had a sample of 300 and 68 of them begin with the digit 1. So P hat is going to be 68 out of 300. And that's going to come out to be 0.2267. I'm using 4 digits, probably safer just to make sure you get full credit in WebAssign and everything. Okay, so this is a little bit different than what Benford's law would say, right? It's not exactly equal to 0.301. So we want to know, is that a big enough difference to make it worth doing a more thorough investigation? And to decide whether our evidence is strong enough, we're going to need an alpha level. I should have put this in the question, but I'll go ahead and give it to you now. We're going to assume the alpha level here is 0.05. That's a pretty common one. All right, let's go through that 5-step process. So we're going to start by stating the hypotheses, always in terms of the population parameter. We've already got the sample P hat. We don't need to do a test for that. So the null hypothesis is going to be that the company's not cheating, right? That it's going to follow Benford's law, and that maybe it just so happened in this sample that not quite as many began with the number 1. And then remember, for the alternative, we have to read carefully to see how the question is stated. So let's see. It just says if the proportion is significantly different from 0.301. So it doesn't say we expect it to be higher or lower. We're just testing to see if it's different. So here our alternative is going to be P is not equal to 0.301. Okay, step 2, we're going to check our conditions. So first of all, we need to make sure we've got a random sample if we want to be able to generalize this to all the expenses at the company. We've got that. We can see it in the setup here. Got our random sample, and we need to check and make sure our sample size is large enough. Remember, it depends on both N and P. So we're going to take 300, that's our sample size. P comes from the null hypothesis, 0.301, and that's going to be 90.3. Definitely bigger than 10, so that's good. And then we also need to check N1 minus P. So N1 minus P, we're getting 300 times 0.699, and that's going to come out to be, what, 209.7, also greater than 10. So that's good news. So our sample size is big enough, our conditions are all met, and we can go from there. So the third step is to calculate the test statistic. So we're doing a z-test. So we're going to take P hat, our sample value, minus the P from the null hypothesis, and then divide it by the standard error. So that's the square root of P times 1 minus P divided by N. So then it's just a matter of plugging in the numbers. 0.2267, that was the one that happened in the sample, minus 0.301, that's from the null hypothesis. And then we're also going to use the null hypothesis values as part of the standard error, 0.301, 0.699, and then dividing by 300. All right, so once we do all of that, calculate it out, we end up with a z statistic of negative 2.8056. So I'm going to wait on the interpretation. I'm going to leave that for you in a minute. Let's go ahead and get down to the p-value. So for the p-value, remember we're going to need that normal distribution. And it's going to have a mean of 0 and a standard deviation of 1. 1, 2, 3. 1, 2, 3. Okay. And our z-statistic here, it's not as extreme as it was last time. Our z-statistic is kind of on the edge over here. So there's our z, negative 2.8056, right? And we're going to shade all the values that are more extreme. But actually, this one's a little bit different. You may have noticed up at the top of the page, it said that this was a two-sided test. And a two-sided test, it comes from the fact that we're going to shade both sides. And how we know to do that is the alternative hypothesis. So anytime your alternative hypothesis has not equal in it, when it doesn't specify greater or less, then we need to consider both greater or less when we calculate our p-value. So we're going to find 0.28 over here, and we're also going to shade this side. All right, so obviously we don't know exactly what the p-value is going to be just by looking at that, since it comes between the standard deviations. So I'm going to have to actually use my JUMP calculator to get that. So we're opening JUMP. We're going to the add-ins, teaching module, distribution calculator. Notice the mean and standard deviation, they're already set to 0 and 1, so that's nice and convenient. And we're going to put in our z-statistic here, so negative 2.8056. That's our z-statistic, but this doesn't quite match our picture yet, right? We want to have it for both sides. So I'm going to pick this one down here at the bottom. So notice it's giving me both sides now, but I want it to match, so I'm going to pick that same value on the other side, 2.8056. And now it matches my picture. These shaded areas are going to give me the p-value. So because of this calculation, I know that my p-value here is 0.0050. So the p-value for both of these sections, p-value comes out to be 0.0050. Okay, so that's actually the last thing I'm going to write down. I'm going to leave the conclusion and everything to you. So the next set of questions, it's going to ask you to do some interpretations. It's going to ask you to draw the conclusion. And at the end, when you're done, it's going to give you feedback, give you the correct answers with a little bit of explanation why. So once you're done with that, don't forget to come back here and write your answers on the page, especially down here at the bottom, some questions about strength of evidence. You're going to want to fill those in.